So in the first sum that we will be seeing, we will be just finding the number of teeth on each and every gear. In the exam, when you get a question, there will be at least one gear whose number of teeth will be missing. And without the number of teeth on all the gears, you cannot solve the question. So we must first learn how to find the number of teeth on all the gears. Okay. So in this question, what you are seeing is an example of reverted gear train. If you remember from our previous videos, a reverted gear train is a special case of compound gear train in which the driving axis and the driven axis is on the same line. Okay, see, this is your driven shaft, this is your driving shaft. They are both on the same line, they are the same axis, and this is your compound gear train. A compound gear train is something which has more than one gear on the same shaft. Okay, so in this example, your driving shaft is connected to gear A. So A is your driving gear. Then A is transmitting power to B. This is A. A is rotating in the clockwise direction and it is transmitting power to B. Because A is rotating in the clockwise direction, B will be rotating in anti-clockwise direction. Now B is directly compounded to C. Okay, see, you can see over here, this is B and this is C. So the RPM of B and RPM of C will be the same. C is then geared to D. So this is our small d. So C is rotating in the anti-clockwise direction, same as B. So D will be rotating in the clockwise direction. And D is our driven shaft. So in this question, they have given us a lot of data. They have given us the modules of gear A and B, which is 6, diameter of A, number of teeth on B. What we basically have to find is the module of gear C and D. We have to find the module of gear C and D, and we have to find the number of teeth on gear C and gear D. Okay, so we will solve this question and you will understand how we can find the number of teeth on different gears. So we will start solving this sum now. So basically what we have to find out is what is the number of teeth on C and what is the number of teeth on D. Before solving that, we will first write down the given data that we have. Okay, so in the given data, we know that gear B and gear C are compounded together. When I say they are compounded together, it means that they are on the same shaft. And if they are on the same shaft, both will have the same RPM. So we know that the RPM of gear B is equal to RPM of gear C. Okay, so gear A is meshed with gear B and gear C is meshed with gear D. As you can see, A and B are meshed and C and D are meshed together. The next thing they have given us is that module of A and B. Always remember, meshing gears have the same module. So module of A is equal to module of B is equal to 6. The next thing they have given us is the diameter of gear A. They have also given us the number of teeth on gear B. They have given us the velocity ratio of C and D. Now if you remember from our earlier video, velocity ratio is the ratio of the RPM of the driven to the RPM of the driver. Okay, so in this case our driven is D and driver is C. So it will be RPM of D upon RPM of C, which has been given to us as 2. They have also told us that the sum of teeth on gear C and gear D is 60. And what they are asking us to find is what is the modulus of module of C, which will be the same as module of D because they are meshing together. Remember, whenever two gears are meshing, they will have the same module. And they are asking us to find what are the number of teeth on C and what are the number of teeth on D. Okay, so to start solving this problem, we can look at one important point. What we can see is these two center points. Okay, let this be x1, let this be x2. Okay, you can see that x1 is the center for gear D and gear A. x2 is the center for gear B and gear C. So what they are basically telling us that this length will be common for both these pairs of gears. Okay, so we can see that length x1, x2, this length is equal to what? Is equal to the radius of A. See, this complete is the diameter of A. This becomes the radius of A and this becomes the radius of B. So length x1 x2, this length x1 x2 is equal to radius of A plus radius of B, is equal to radius of A plus radius of B, which is also equal to, see, this distance is also equal to radius of D plus radius of C, radius of D plus radius of C. So from this, what can we say? Radius of A plus radius of B is equal to radius of C plus radius of D, right? Now if I multiply both these with 2, both these sides with 2, that is this side with 2, this side with 2, what am I going to get? 2 into radius of A. 2 into radius of A is diameter of A. 2 into radius of B is diameter of B. Similarly, diameter of C plus diameter of D. So this is the equation that I get. Okay. Out of this, diameter of A is already known to me, 150 mm. What about diameter of B? I don't know the diameter of B, but yes, I know one thing. What do I know? I know the modulus of B and I also know the number of teeth on B. And from my formula, I know that module is equal to diameter upon number of teeth. Therefore, diameter becomes module into number of teeth. Okay, so remember this formula. This is an important formula for solving gear sums. Okay, diameter is equal to module into number of teeth for any gear. Okay, so for diameter of B, what can we write? Module of B into number of teeth on B. Similarly, what can we write for DC and DD? We can write module of C into number of teeth of C plus module of D into number of teeth on D. Okay, so we got all this data. Now from this we know module of B, module of A is equal to module of B is equal to 6. We can substitute it. 150 plus 6 into number of teeth on B is 15. Okay, so from this, we know that C and D are meshing together. If C and D are meshing together, they will have the same module. Let us call that module M. Okay, for now we will call it, okay, we will call it MCD. Okay, so MC is equal to MD. Taking it out common, we get MCD into TC plus TD. Okay, we don't know the value of MCD. We have to find out C. We have to find out the module of C and module of D. But we know the value of TC plus TD. They have given us the total of TC and TD, which is equal to 60. So we can substitute it over here. Okay, so what will we get? Okay, I'll write it over here. 150 plus 15 times 6 is 90 is equal to module CD, which is unknown to us, into TC plus TD is 60. Okay, so what do we have? 150 plus 90 is equal to module of CD into 60, implies 240 is equal to module of CD into 60, which means module CD is how much? 240 divided by 60 is equal to 4. Thus, we found out the value of module of C, which is equal to module of D, which is equal to 4. Okay, now we have to find out the number of teeth on C and number of teeth on D. Okay, to find this out, see, they have given us the velocity ratio. What is the velocity ratio? Velocity ratio is the speed of driven upon speed of driver. So ND upon NC, which is equal to what? 2. Okay, so ND upon NC is equal to 2. Now from our earlier equations, we know that ND upon NC is equal to Tc upon Td. Okay, that the RPM of D upon RPM of C is equal to number of teeth on C upon number of teeth on D. This has been explained in the previous videos. Okay, so from this we can say that Tc plus Td equals to 2, but we also know that Tc plus Td equals to 60. Tc plus Td equals to 60. So taking this Td over here, we get Tc equals to 2 times Td. Taking Td onto the left side, we get Tc minus 2 times Td is equal to 0. So this becomes my equation 1. This becomes my equation 2. These are two simultaneous equations. We can solve these simultaneous equations using a calculator. Okay. So mode equation. Okay. What is given? Tc plus Td is equal to 60. Tc minus 2 times Td is equal to 0. We get Tc as 40 and Td as 20. Okay. So these are my answers. Tc is 40 and Td is 20. Okay, thank you.